As introduced, I'm Florian Gilcher. The topic of my talk is fear of adding processes. A friend of mine misheard that as fear of adding process at the first try. What I'm going to talk about is fear of adding programs to your system, not about fear of adding workflows to your company. Who am I? I'm a Ruby programmer since 2004. I founded my own company like 2 years ago, and I'm mainly committed to back-end work. I'm not doing any front-end anymore, and I'm mostly working for my company and Padrino. It's the same again. Before that, before I started using Padrino, I worked with Rails from 0.14 to 2.0 and switched before 3.0 came out, so I don't have an opinion on it. And I do also participate in running one of the largest German Ruby bulletin boards, while large for a bulletin board nowadays is like 100 users. If anyone is interested in, yeah. Mikro ist kaputt, ich habe das andere gerade wegnehmen müssen. Ja. Das ist nur das für die Kamera. So, okay. I try to speak even louder. It's fine now? Okay. If anyone's interested, I can do an open space session about Padrino tomorrow. If you want to, please contact me on Twitter. So, one of the ideas behind this talk is actually one of the greatest talks I ever heard on any Ruby conference, The Fear of Programming by Nathaniel Talbot. Has anyone seen the talk? If not, do it afterwards. It's a long talk about actually not doing things because you have an uneasy feeling about it, although you think that it's the correct thing. And the other one from the Venerable C2 wiki, they have a pattern they describe as a fear of adding classes in object-oriented systems. It's basically the same thing. You could solve a problem by adding another component to the system, but you don't do it because it's work. You have to add a file, you don't know how it works out, and then you don't do it. And basically, the fear of adding processes is the same. It's the opinion that once you start another process in your system, it immediately gets more complicated and harder to manage. That's not always the case. It might be, it might not. And this is basically what this talk is about. I make a lot of fun about CTOs from time to time, and mostly about those that always follow trends. As you can see, there were like 3 proposals in this conference about distributed systems. And yeah, I've seen it happening that people just enter a room and are like, yeah, let's implement a system using multiple small services, a database, and a caching layer. Everyone's like, yeah, it's nice. And then they just hack along, do nothing, don't think about it. They just hack their services, their caching layer, and everything. And 4 weeks later, you're in a Munch painting. This is not good. The thing is, what they ignored is that there's a certain kind of uneasiness attached to it. And if you're doing this, implementing a large system, and you're not uneasy about any parts of it, you have a problem. We fear unknown grounds, usually, and there are good reasons for that. That doesn't mean that we shouldn't go there. To go there, you should basically think, how do I solve that uneasiness that I feel? Is there any technical or otherwise any solution to solve this? In programming, we do that by code review and stuff. When we're building distributed systems, we have to pick other tools. So let's talk about the fears in specific. The first fear that I picked is, actually, I think this is a good way of implementing it, but I don't know whether my reasons are right. And in the end, maybe they weren't. And I've got a tiny example for that to see what kind of systems we're talking about. One of our clients imports and re-encodes video from a constantly changing number of sources. So they have partners delivering content from month to month, every day. Contracts are broken, contracts are reoffered, everything. What they have to do with those videos is they have to encode them afterwards to use them in their platform. And the sources are, FTP upload, FTP fetch, RSS feeds. There are people that tell you that they have RSS feeds, and once you look at them, they aren't. So you are writing a custom importer again. And internally, we're using those videos in like 2 different sizes, and we do some snapshots of them and provide them to other people. So the boring implementation in a piece of software in one process would be, I have an importer, I have an encoding step, I just put them behind each other, fine. If I do a bit more, and maybe I'm on JRuby, I could use one of the queue classes that are provided by Java. I could have importers that put videos into a queue and have an encoding process or an encoding thread that encodes them. The third option would be to write 3 programs. One imports, puts all the stuff into a queue. In our case, that's Kestrel, the queue that Twitter uses. And then there's another program that just pulls each of the metadata and files from the queue and encodes them. So the big question is why? That's definitely a bit more of work than just writing a program. One. Now, they're specializing in high quality video, so there's not a lot of videos each day. It's like 400 if they're on a peak, and 400 videos of 5 minutes, I could do that on my laptop. By hand, maybe. Second thing is failures during the last year, and now we're getting closer. We didn't have any failure in the encoding process. The queue didn't fail us once. It was deployed once, done. But the importer failed a lot. And the number that was really interesting is how many times did we deploy it? The importer is always deployed. As I told you, that's the piece where everything is changing all day, while taking a video on the left and encoding it to a different format on the right doesn't change over the year. It's still the same task. So basically, we have 2 elements that are always performing the same task and one that is constantly changing. And that's the big benefit we had from doing this. We can deploy one part of the system basically at any minute. So here's my first guideline. If you're thinking about distributed systems, don't think about performance first. It's a big error. Also, don't think about implementation too much. Think about, where is my operational benefit in this? Does it help me that I have a completely split up system in which I can theoretically bring down and bring up every piece at any minute? So some other examples there. The first one is pretty common. You have a home page that is basically advertising your product, that is basically managed by a designer, and you have the actual product. It's like if any one of you is using Harvest, that's their model. The Harvest website is something completely different from the Harvest product. The same on big websites that have a site and a management backend in behind of it. You could put that into one big Rails app, or you could split it out. Basically, any software where you have 2 pieces with widely diverging needs or implementations. So, fear number 2. That's a lot of work to set up. And yeah, that's true. But we can do something against it. And the first thing is get a unified development environment. That's not as easy as it sounds. I saw this happening. Along comes the CTO and gets everyone a Mac. Great. Well, and some €1,000 later, nothing was unified. what happened? We are all developers. We want to tinker with those things. I think my libxml on this machine is horribly broken. I don't know why, but I didn't come around to fix it. And Apotenik doesn't have Mac. So you can't hire him. Bad luck. Does anyone know this guy? Not a lot of people. OK. That's Vagrant. Vagrant is a really, really cool piece of Ruby software, my favorite during the last 2 years. You can find it on Vagrant app. And basically, it's a scripting toolkit for Virtualbox. What it does on top of Virtualbox is distributing virtual machines, running them, destroying them. You can do, basically, once you have it, suddenly the number of virtual machines on your laptop rises. I have like 20 at the moment. And so what you can do with Vagrant is you just get Virtualbox, install your production OS in one of those virtual boxes, and get started. Problem, it's still a lot of work to set up. So now I have an operating system in a virtual machine. Basically, everyone can use the same, but we're not running our applications on our operating system, but we have a whole lot of stack on top of it. Automate that immediately. If you want to run 5 or 6 different programs in your production environment and you haven't got that automated, you're just running into a big wood with your eyes closed. Vagrant has a Puppet and Chef integration, and it's really, really good. So what we do in most of our projects is we have a big repository that basically encodes how each of the environments that we have looks like, including the development environment, also with developer toolchain and everything. So where we want to come to is that the first thing a new guy can do on any machine, Linux, Windows, OS X, comes into the office, clones that repository, and just says Vagrant up. And if it's all handled under version control, he will get the actual development environment at that day. And if you change anything on that, make sure that you have code review in the whole team, and that all changes to all environments are reviewed by someone else. And as I was talking about new developers, they're a great chance to revalidate whether your system is working. So once you finish with all that stuff, that's the end of a Puppet run, you can basically check it. If it looks like the guy on the left, you did all right. If it looks like the guy on the right, you wrote something horrible. And 2.99 in all that development environment stuff that I hear all too often is my IDE doesn't support this. I have the opinion that IDEs should support you, and if they don't, in what you want to do, and if they don't, there's still that drag and drop feature. Fear number 3. We're introducing a whole lot of complexity there on an architectural level. The programs by themselves get easier to manage. But yeah, how do we handle this kind of complexity? The first thing is use global configuration. So if you start running around in all your repositories and set the development database to some magic value, you're getting mad. Use your environment for that. It's basically the oldest way of getting information to each of your programs. So in the end, your configuration file could look like this. It's also a lot shorter than your usual database.yaml. And it could look like this on any of your tiny programs. The second thing is that is often forgot. Centralize everything that can be centralized. The first thing is logging. And if you're using metrics, those as well. And do that in development so that you know that this is working. One of the also oldest tools to do this is syslog. It has an absolutely nice feature, which is a log error, log p error, which basically says behave like the normal Rails logger, but also log to syslog. So it won't have any changes. You change the logger of your software, but it doesn't have any visible changes to you in your development environment. The other part of this is have tools for everything. There's a big problem if you have inter-process communication and you don't know how to hook in between. And I've seen more than one place where actually you had an API, a front end talking to a back end, but there was no way to fake calls to the back end. So everyone was using that big front end software and tried to find the place where you could actually emit the call that tested the fault in your back end. Don't do that. Even if your support scripts are as short as this is actual project code, make it as easy as possible to talk to the backend. It's a JSON backend, so we have a script that uses the standard user and the standard password. This one is deleted, and the standard content type automatically. And if you know curl, you can then easily post a document to our backend API just by using this. If your developers have to do the whole command all the time, that you have to explain to every newbie, you're having a lot of work and a lot of uneasiness as well. Also seen all too often, if you're implementing command line things, use a proper command line parser. Trying to parse argv by hand, and then no one understands which argument is actually which isn't very good. And document all this. And the last piece of Ruby that I'd like to show that comes really handy is Foreman. It's anyone here using Foreman? A lot more. It's basically the process manager of Heroku. And what it allows you to do is make a list of things that should be running once your application is running. You can also tell it to start the API twice and the website only once if you have a read-heavy API. And if you want to go as far as even starting your databases with it, do it. And what it gives you is, I'm jumping ahead one slide, a really nice unified log of everything that's happening in the thing you're actually working at the moment. So you could even inject something else. For example, I usually, if I'm working with Redis, I also have another process that monitors everything that happens on Redis just by calling monitor, and another one that's passing my Nginx error logs. So I have my production configuration of Nginx running on a VM. And so all the things that are at error when it comes to Nginx will also be in my development log if there is any error before it hits the web app. It's a really handy trick and really easy to implement to see what's going on into any piece of your software. And last but not least, the more programs you have, the more important code ownership becomes. Basically, most programmers don't care about the programs of others, is my impression. So make sure that everyone has its little child that he cares about and makes clean. And it becomes really important once you can basically miss developing on any piece of the platform. So finally, the classics, pitfalls. What can happen to you if you're implementing such an architecture? The first thing is doing it because it's cool. It's basically the first point. You will run ahead without thinking too much about it and finally find out that it's hard to manage. The second is disorganization. All this stuff I just presented is basically present in all other kinds of software development as well. It's basically just good organization, but it gets much more important because you have to make sure that it happens onto each one of those pieces of software that you're implementing. And the third one, sadly not so uncommon, is the distributed rewrite. I have a big monolithic application, and yeah, I could just break apart little pieces of it and reintegrate them into the bigger part until I can destroy the big part. And the problem is that's never happening. I've never seen such a system. Basically, you had a lot of tiny, small, nice worker bees and a totally mutilated but big corpse of an application that is still running and horrible to maintain. Just drags you down. Yeah, that's about it.
So we got a couple of minutes. Do you have any questions, maybe?
I like the idea you presented of using Vagrant and using production-like environment, running on some kind of Virtualbox or something like that. But right now I'm having problems with things, with testing new features that are connected with the fact that my application needs to be aware of this, that it's distributed and it is running on more than one node. So some features are tested by developers on their machines, but not everything can be tested properly, just because of the fact that one node is not working the same way like there are many nodes. So do you have any idea how is it possible to use those suggestions, but for more than one node running the application?
Vagrant has a multi-VM mode. So you can basically start up 4 virtual machines, give them all IPs, or we actually work with domains, and then you just kill one of them. Yeah. It takes a bit longer to boot. Actually, what we're doing is we're using very small VMs with 1 GB of RAM at most. It also has the nice benefit that you find memory leaks very quickly in development.
Any more questions?
Martin Fowler once said, my first law of distributed systems is do not distribute them. And what do you think about it?
I think it's a good rule of thumb. The thing is, it sounds cool. It's all, we had that software-oriented architecture thing back in the 90s and early 2000s. I think many people underestimate how much work it is to manage that. On the other hand, if you find a problem where it really fits as a solution, for example, backend workers in Rails are basically this concept. If you're using any of the backend worker implementations, they are mostly based on this concept. So I think it's a good rule of thumb. Don't do it easily.
Any other questions? No? All right. Thank you very much.
Thank you.